Welcome to the final presentation of this series on aviation map reading. This is exercise drone search. The aim of exercise drone search is to consolidate the learnt knowledge through the course and demonstrate aspects of crew resource management. It's going to be done by a mini airborne navigational exercise, or NavX, trying to find locations on the ground by use of distances and bearings and an aerial photo. In the end state, well, the student will feel more confident in working in and around aircraft and demonstrate how safe she or he could be, and will also have a better understanding of the complexities of aviation operations and demonstrate various crew resource management skills as well as aviation map reading. So here's the scenario. The Department of Primary Industries has been using a remotely piloted aircraft, commonly known as a UAV or a drone, to chart locust bands. Unfortunately, it's malfunctioned and suspected to have crashed because it's way past the life of the battery. It contains some hazardous materials such as laser equipment and a lithium polymer battery, and they pose a danger to persons on the ground. So your mission is that your team has been asked to do a quick search for the suspected crash site using a helicopter and some limited information. You are then to pass the intelligence that you gather back to the chain of command so that can be used by members of ground search crews who are looking for the UAV. Execution, how are we going to do it? Well, the syndicate teams of 3 or 4 persons will be asked to do some basic flight planning and then board the aircraft, demonstrating safe working around aircraft. Brief the pilot on what he or she is required to do, and then commence the search using their flight planning information. When you return from your mission, the intelligence that you would have gathered will then be converted into useful information and passed via email or briefing or some other means to the chain of command. Successful completion. Well, success will be measured against the following criteria. There will be no breaches of safety. The flight planning will be done correctly. The briefing and assisting the pilot will be effective. You'll locate all the sites on the ground, and you'll gather that intelligence and send it to the chain of command using whatever means necessary in a format that is usable to the chain of command and ground search parties. The assessment. Safety will be assessed. If you breach safety and knowingly do so, that will result in a fail grade on the course. If you make a mistake, that's a different matter. That means you need extra training. But if you violate any rules of safety, it's an instant fail. Other skills will not be assessed, but you will be monitored on them and reported on, and any extra training provided where necessary. We just want you to get the best out of this exercise as we can. And the winning syndicate will be rewarded. So flight planning. The drone has beamed back some data to the ground control station. So each leg of the mission was recorded, but only recorded as a distance and bearing in meters and degrees true. Well, that doesn't really help us. It also sent back an aerial image of the waypoint, but it didn't provide any position information or bearing information, like we don't know which direction was north. So with the information given, this is what you need to do. Convert that information into data that the pilot can use. Brief the pilot on the mission, including the tracks that he or she has to fly and the ground speeds that he or she has to fly. Then fly the route from a known starting point and try and locate each waypoint on the ground and match it to the aerial photo that we will be giving you. Annotate where north is on the photo. Confirm the location using a smartphone app or a digital camera or whatever at each waypoint. And then locate the final waypoint, and upon return, plot the route flown on a topographical map and give that map to the incident management team so they can send a ground party to recover the drone. Here's an example of the aerial photograph we will be providing you. This is for waypoint 5. As you can see, it's a junction of 3 roads, but we don't know which direction north is. We're not quite sure where it is, so you need to go and find it, take a photograph of it, and tell us exactly where that position is on a map. Here is the information that we'll be giving you. So for example, at the top, Syndicate 1 will be doing route alpha. So from the starting point, they'll go to waypoint 7, and the distance from the starting point is 5,260 meters on a bearing of 342 degrees true. So you'll need to convert that into nautical miles and magnetic, which is what the pilot can use, and then figure out how long it's going to fly you and at what speed from the start point to waypoint 7. So the idea is you start the clock as you fly over the start point, you fly at the ground speed that you've calculated for the length of time that you've calculated, and once the timer comes down to 0, you should be flying directly over waypoint 07. Compare that location with the aerial photograph, annotate where north is, get a latitude and longitude or an MGRS grid reference, and then do the same again to waypoint 3, using waypoint 7 as your start point. And then fly 6,476 meters on a bearing of 106 degrees true, and obviously you'll be converting that information so the pilot can use it, for a specific time at a specific speed to try and find the location of waypoint 3, and then do the same to get back home. So each syndicate will be given a different route, and then you'll provide that information to the pilot and brief the pilot, and then actually fly the mission and take those photographs and annotate them.